So this is problem 217 for standard 2.2. So the question gives you a spin 1 particle in this state right here, and it asks you to find the possible results of a measurement in S of z. And so since it's a spin 1 particle, there's 3 different options. It can be either plus h bar 0 or minus h bar. And this matrix here represents the matrix of a spin 1 system. So this first one corresponds to the plus h spin. This spot corresponds to the 0 spin. This one corresponds to the negative 1 h bar. So then when we're finding the probability of getting a plus h, it turns out to be just 1 over the square root of 30 times 1, and that squared. So the probability of it being plus h is 1 over 30. The probability of 0, so next we're looking at this part, and so it's 1 over square root of 30 times 2, that squared, so we get 4 over 30, which is just 2 over 15. And then the probability of getting a negative h bar, so now we're looking at 5i, is just 1 over square root of 30 times 5i, and that's squared, and that turns out to be 5 over 30, which is 1/6. So next it asks for the expectation value for this, and so to find the expectation value, it's given right here. It's the sum of the eigenvalues times their respective probabilities. So we're using the answers from the earlier part. So it's h bar times 1 over 30 plus 0 h bar times 4 over 30 minus h bar times 1 over 6, and that equals minus h bar 4 over 5th and 4 over 5. And that's our expectation value. So part B asks for the expectation value of the spin component Sx. And so to find that, we use this, and we can use matrix mechanics to find this. So the matrix representation of the Sx operator is given here as h bar over square root of 2 times this matrix. And so using this, we can rewrite this as this down here. And then so now it's just matrix multiplication and also scalar multiplication. So I move the h bar over square root of 2 out here. Then I multiplied this vector times, this matrix times this matrix, and this was the result. And then next I multiplied this 3 by 1 matrix times this 1 by 3 matrix, and then I multiplied by the scalars, and this was the result. And so the expectation value in the S of x is just 4 over h bar times 30 over square root of 2.